Find skew and skewness of uniform probability density function for a random variable. So uniform probability density function we have discussed now. Fx of x is equal to what? 1 by b minus a for a less than or equal to x less than or equal to b. We solved this problem already. We found what is the mean of uniform random variable. Mean x bar is equal to what? A plus b by 2. And variance, what is the variance we got? The variance is equal to a minus b square by 12. Okay, just now we have discussed no this. Okay, in the previous class. And now we have to find out skew and skewness. The skew is given as mu3 is equal to x cube bar minus 3x bar sigma x square minus x bar cube. Okay, now we have to find out what is the third movement. What is third movement here? X cube bar can be written as integral minus infinity to plus infinity x cube fx of x dx. Okay, now it is 1 by b minus a. What are the limits now? 1 by b minus a is defined only from a to b. So the limits are from a to b x cube dx. Okay, so it is equal to 1 by 4 b minus a. Now after doing this integration and substituting the limits, what is the third central moment we got? Third moment we got it as x cube bar is equal to b power 4 minus a power 4 divided by 4b minus a. Okay, now you know what is x cube bar minus, and x bar also we know, and we also know the sigma x square and x bar also we know. We substitute all these values here. So this value, see here, x cube bar, we already found just now. It is b power 4 minus a power 4 by 4 into b minus a minus 3. What is x bar? It is a plus b by 2. And what is sigma x square? We got it as a minus b whole square by 12 minus a plus 3 whole cube by 8. Okay, after solving this, we got what is mu 3? Mu 3 will be equal to 0. So what is the skew of uniform random variable is 0. So what is skewness? Skewness is also 0, because skew is 0, skewness will also be 0. Okay. So now we'll discuss what are the functions for movements. Okay. Now to calculate nth movement of a random variable x, okay, we have two functions. We can use these functions to find out nth movement of a random variable. That is characteristic function and movement generating function. Okay. So the characteristic function we'll be discussing here. The consider a random variable x with the probability density function fx of x. Okay. Then the expected value of e power j omega x is called characteristic equation. So how do we denote? We denote it as phi x of omega. What is phi x of omega is the characteristic equation. What is the formula to find out the characteristic equation is? It is expected value of e power j omega x, where x is a random variable. Okay. Now here the omega is a real variable. Its value is varying from minus infinity to plus infinity. Now use the expected value formula here to find out fx phi x of omega. It is integral minus infinity to plus infinity e power j omega x fx of x dx. Okay. Similarly, for discrete random variable, the characteristic equation is given as phi x of omega is equal to summation I e power j omega xi p of xi. Okay, instead of what is that here? Instead of density function, we will be having probability mass function. It is probability of xi. Okay, and here also here it is a continuous random variable, whereas here it is discrete random variable. To denote discreteness, we are using xi. Okay, so it is e power j omega xi p of xi. So this gives us what? Characteristic equation for discrete random variable. Okay. So what is the importance of characteristic equation? The characteristic equation transforms the random variable x into another real variable omega. So if you observe this characteristic equation, what is this? It is function of omega. Whereas our original signal, see here, the signal is function of x. Now it is transformed the domain x to omega. So the characteristic equation transforms the random variable x into another real variable omega. So what is this? Characteristic equation is nothing but the Fourier transform. It is the Fourier transform of what? Fx of x. Okay. Fourier transform of probability density function. Okay. So what is here? Only the difference here is the characteristic equation will be having the signs of omega will be reversed, whereas the Fourier transform will be just the signs of omega. If you reverse the Fourier transform of fx of x will give us the characteristic equation. Okay. And similarly, to find out inverse Fourier transform. What is inverse Fourier transform? If phi x of omega is given, you can able to find out the probability density function with the sign of x is reversed, because what is sign of x here? The sign of x is reversed, no? That is why. So once we know the characteristic equation, we can obtain the probability density function with the sign of x is reversed. Okay. So what is fx of x here? Fx of x is equal to 1 by 2 pi integral minus infinity to plus infinity phi x of omega e power minus j omega x dx. Okay. Whereas for inverse Fourier transform, here we will be having plus. But since here it is the characteristic equation, here we have minus. Similarly, for Fourier transform, what is that we will be having now? Here we have minus, no, but characteristic equation it will be plus. So the sign will be reversed. Sign of omega will be reversed. So the function phi x of omega and fx of x are Fourier transform pairs with the signs of variable reversed. Okay. Instead of minus there, we have to have plus here. Whenever we have plus, we should have minus. So this will form Fourier transform pairs with the signs of variable reversed. Okay.